Thank you everyone. Today I discuss about resistivity or specific resistance. First of all, you have to know the resistance depends on main four factors. Resistance. This resistance, not resistivity, resistance depends on four factors. What are they? They are material of the conductor, number 2, temperature, number 3, length of the conductor, and number 4, cross section. Length, it is indicated by small l. Cross section, it is indicated by capital A. On these four factors, resistance depends on. If the temperature and the cross section of any conductor remains constant, then the resistance R is directly proportional to L. Here temperature and cross section both remains constant, and if the temperature and the length, if these two are remains constant, then resistance is inversely proportional to cross section. Here temperature and length are constant. Here temperature and cross section remains constant. Now if you apply the joint variation rule on that two relations, then what you get? Here R is directly proportional to L, where temperature and cross section are constant. R is inversely proportional to cross section, where temperature and length are constant for a particular conductor. If we apply the joint variation rule here, then what you get? You get R is directly proportional to L into 1 by A, where cross section and L are both variable. But temperature is constant. Here the temperature only constant. Here cross section and the length both of the conductor are variable. Now if you want to remove this proportion sign, then what you get? To remove the proportion sign, then you get a equal sign and a constant. So it will be R is equal to a constant. This is a constant rho L into 1 by A. In mathematical language, this rho is a variable constant. Variation constant. But in physics, this rho is known as resistivity or specific resistance. So the formula will be R is equal to rho L by A, where rho is equal to resistivity or specific resistance. Now the question is, how do you define this resistivity? Here, now this resistivity is applicable for the material of the conductor, but the resistance, it is applicable for the conductor. Now, how you define the resistivity? From these two relation, what you get? You get R is equal to rho L by A. From this relation, here you get R equal to rho L by A. By simplifying, you get rho is equal to R A by L. If you put L equal to 1 and A is equal to 1, that means length of the conductor is unit and the cross section of the conductor is also unit. Then if you put A equal to 1 and L equal to 1, then you get rho is equal to R. And from this you get the definition of resistivity. Resistivity is the resistance of a conductor having unit length and unit cross section. That means if you take a conductor of unit length and unit cross section, then this conductor have resistance. This resistance is taken as resistivity of the material of that conductor. Material of that conductor. Now the question is, what do you mean by unit length? In SI system, unit length means 1 meter. Unit cross section, it means 1 meter square. That means if you take 1 meter long conductor whose cross section is 1 meter square, then the resistance of that conductor is taken as the resistivity of the material of the conductor in SI system. Now here the resistivity always applicable for the material of the conductor. Take one example. Say two conductors. Both are made by the same material. Say it is made by, they are made by copper. Say it is a conductor and it is a conductor and it is another conductor having different length and different cross section, but both are made by copper. As they made by copper, so resistivity of both will be same, as they are made by same material, but they have different resistance because of they have different length and different cross section. So resistivity of these two conductors, the ratio of these will be 1:1. Now this resistivity when measured, then you want a unit. What will be the unit of this resistivity or specific resistance? We know that rho is equal to R A, it is R A by L, resistance into area by A. So unit of rho specific resistance or resistivity depends on the unit of resistance, unit of cross section and unit of length. Unit of resistance, it is ohm, into resistance of cross section, it is meter square. Unit of length, it is meter. Cancellation is there, meter. So unit is ohm meter. This is the SI unit of conductivity, resistivity or specific resistance. Now here the another question. Is the resistivity totally constant? No. Resistivity is not a universal constant. Is not totally a constant. Resistivity depends on two factors. What they are? One is the material of the conductor. If the material changes, the resistivity changes. If the conductor is made by copper and another conductor is made by aluminium, so the resistivity will be different. That means resistivity depends on the material. Second one, the temperature. If the temperature changes, the resistivity also changes. So resistivity depends on, first one is the material. If the material changes, resistivity changes. Number two, it is the temperature. If the temperature changes, also resistivity changes. For that, you take one example where the temperature, with the change of temperature, resistance also changes. Say aluminium conductor. Now aluminium, resistivity of aluminium, it is 1.60 into 10 to the power minus 8 ohm meter, the SI unit. This resistivity of aluminium, it is for temperature 20 degrees centigrade. If the temperature changes, this resistivity also changes. That means temperature increases, the resistivity also increases with the increase of temperature. Now the question is, what is the meaning of it? The resistivity or specific resistance of aluminium is 1.60 into 10 to the power minus 8 ohm meter at 20 degrees centigrade. Means a conductor, that means a aluminium conductor having length 1 meter and cross section 1 meter square have resistance 1.60 into 10 to the power minus 8 ohm, not ohm meter, because it is a resistance. That means if you made a aluminium conductor whose length is 1 meter, whose cross section is 1 meter square, then this aluminium conductor offer a certain amount of resistance, and this amount of resistance will be 1.60 into 10 to the power minus 8 ohm. That means the resistance of a aluminium conductor having 1 meter length and 1 meter square cross section have resistance are equal to 1.60 into 10 to the power minus 8 ohm. This is the resistivity. Again I say, the resistivity and the specific resistance both are same, and they are applicable for the material of the conductor. They are not applicable for the, that is, resistance is applicable for the conductor. they are not applicable for the conductor. It depends on the material. And the resistivity, it is also known as specific resistance. Thank you.